Assalamualaikum and a good day to all of our viewers. As usual, our session will introduce new discussion every day. And as for today's topic, our topic is enzyme immobilization. What is exactly an enzyme? According to Kobil Advanced English Dictionary, an enzyme is a chemical substance, a chemical compound which is found in living creatures, which produce changes in other substance without getting changed in itself. In other words, it behaves exactly similar like a catalyst, which speed up chemical reaction. The biological process that occur within all living organisms are chemical reaction, and most are regulated by enzyme. Without enzyme, many of these reactions will not take place at acceptable rate. Enzyme catalyze all aspects of cell metabolism, such as nutrient digestion, transformation of energy, and construction of cellular macromolecules.
There are many types of enzymes that exist around us. Heck, there are even enzymes inside our body. Did you know that? Here's some example. First of all, there is this proteases and peptidases enzyme which functions to split proteins into small peptides and amino acids. They are produced in stomach, small intestine, and pancreas. And then we got lipases to split fat into 3 fatty acids and a glycerol molecule. Gastric lipase are produced in stomach, and pancreatic lipase are produced in pancreas. Oh, don't forget about amylase, which split carbohydrates such as starch and sugars into simple sugars such as glucose. Alpha amylase, called ptyalin, is produced by the salivary glands, whereas pancreatic amylase is secreted by the pancreas.
So today, our first guest, Dr. AIDA from University of Adelaide, will explain more regarding the method of enzyme immobilization. So, Dr. AIDA?
Thank you, AMAR. Okay, so I will explain about method of enzyme immobilization. There are 5 methods, and the first method is adsorption. Adsorption involves the physical binding of the enzyme on the surface of carrier matrix. Carrier may be organic or inorganic. The process of adsorption involves the weak interaction like van der Waals or hydrogen bonds. Example of carriers are silica, bentonite, and cellulose. Okay, for the second method is called entrapment. In entrapment, the enzymes or cells are not directly attached to the support surface, but it's simply trapped inside the polymer matrix. Enzymes are held or entrapped within the suitable gels or fibers. It is done in such a way as to retain protein while allowing penetration of substrate. It can be classified into lattice and microcapsule types. There are 3 examples in method entrapment. The first one is inclusion in gels, such as polyacrylamide gel and polyvinyl alcohol gels. The second example is inclusion in fibers, such as cellulose and polyacrylamide gels. And the last one is inclusion in microcapsules, which is polyamide and polybasic acid chloride monomers. The next method, which is the third method, is encapsulation. Encapsulation involves enclosing the enzyme within semi-permeable polymer membranes, such as semi-permeable collodion or nylon membranes in the shape of sphere. The fourth method is covalent binding. Covalent binding is based on the binding of enzymes and water-insoluble carriers by covalent bonds. The functional groups that may take part in this binding are amino acid, carboxyl group, hydroxyl group, imidazole group, phenolic group, and others. So, the last method is cross-linking. Cross-linking involves intermolecular cross-linking of enzyme molecules in the presence or absence of solid support. The method produces a three-dimensional cross-linked enzyme aggregate, which means it is insoluble in water, by means of a multifunctional reagent that links covalently to the enzyme molecules. Okay, I think that's all from me, which is the 5 methods of enzyme immobilization. Amar?
Nice explanation from Dr. Aida. Well, next we will learn more from Dr. Husna from the University of Queensland about the industrial application of the immobilized biocatalyst.
Thank you, Amar. For industrial application of the immobilized biocatalyst, there are several industries that use enzyme immobilization technology. First of all, in food industry, pectinases immobilize on suitable carriers used in production of jams, jellies, and syrups from fruits and vegetables. Pectinases are used for the preparation of wine and fruit juices, and one of the important upcoming enzymes of the commercial sector, especially for fruit juice industry. It was set as prior condition for obtaining clarified and stable juices with higher yields. It is also used in apple juice preparation to facilitate pressing or juice extraction and to aid in separation of a flocculant precipitate by sedimentation, filtration, or centrifugation. For detergent industry, immobilization of lipases is used for effective dirt removal from clothes stain. Lipases are added to detergents such as in household and industrial laundry, dishwashers, where the function is in the removal of fatty residues and cleaning clogged drains. The enzymes such as protease, amylase, cellulase, and lipase are added to the detergents in order to improve their efficiency in removing cloth stain. Laundry detergents are becoming more and more popular because of their increasing use in washing machine, where it imparts softness, resiliency to fabrics, anti-staticness, dispersible in water, and mild to eyes and skin. In wastewater management, enzyme immobilization technology is used in treatment of sewage and industrial effluents. The use of immobile enzymes in effluent treatment as compared to free enzymes result in multiple advantages like increased stability, ease of handling, reduction in running costs. Horseradish peroxidase covertly immobilized into magnetic beads, retain a high activity and stability, and perform higher phenol conversion. Okay, that's all from me. Thank you, Amar.
Wow, as expected from Dr. Husna, the immobilization of enzyme carries huge potential to be improved in the near future. So, for example, one of the biggest issues regarding enzyme immobilization is how to recover an enzyme in the most efficient way. Maybe in future, instead of enzyme being destroyed or denatured, during chemical reaction we can develop a proper medium to extract the immobilized enzyme. And then, perhaps we can reactivate the active site of those said enzyme through reverse engineering. In that way, we can reuse the enzyme and thus removing the need of fresh enzyme supply during the start of every chemical reaction. That would be a good concept. So, that concludes our session today.
That's all from us.
Thank you. We will be again.
Yeah.